Hello everyone, welcome back to our channel. We were discussing trigonometric functions, class 11th maths ncert. We've already completed two parts of it. In this third part, we'll continue our discussion of trigonometric functions. Now we know that if your x and y axis, if this is your x-axis, x dash, and this is your y-axis, y dash, it divides the whole plane into four parts. Now these four parts are called quadrants. Quad means four. Quad means four. So four parts, four quadrants. This is first quadrant, second, third, fourth. In the first quadrant, x is positive and y is positive. In the second quadrant, x is negative, y is positive. Third quadrant, x is negative, y is negative. And fourth quadrant, x is positive, y is negative. This much we already know. Now, let's consider a circle with unit radius. Unit means unit length. It can be anything from meter, centimeter, any length of any unit of measure. Let's consider OP. P be any point in the first quadrant lying on this unit circle. The circle has its center placed at the origin 0, 0. The other coordinates of this origin. X dash, y dash. This is understood. With this, let's consider A, B to be the coordinates of this point P in the first quadrant. By observation, we can name these points. Let's call them A, B, C, D. By observation, we can name these, we can write the coordinates of these points. So A is 1, 0, B is 0, 1, C would be -1, 0, and D is 0, -1. Now, from here, let's draw a line from this P perpendicular to x-axis. Now, can you say that this point, let's call it R. By observation, can you say that OR is A? For this point P, A, B means x coordinate and y coordinate. A is x coordinate, B is y coordinate. So this x coordinate is from distance from y-axis and y coordinate is distance from x-axis. So distance from y-axis, this distance will be parallel to this distance, which is A, and this value will be B. This is 1 unit by assumption. Applying trigonometric ratios, we know that in triangle ORP, R is 90 degree. So this angle, let's consider this angle as x. Cos x is equals to adjacent upon hypotenuse. Adjacent is A, hypotenuse is 1, A upon 1, which is equals to A. And sin x will be equals to opposite upon hypotenuse. Opposite value is B, hypotenuse is 1, so this value is B. So the same coordinates of P, A, B can be written as cos x, sin x. Now this point P can be any point in any of the any point of lying on the circumference of the circle in any of the four quadrants. Irrespective of that, the value of P will always be cos x, sin x. Now, at these points A, what happens at point A? At point A, we observe that cos 0. Why 0? Because x will form 0 angle. Its initial side and final side are the same. So x is 0 at point A. OA will form 0 angle with itself. Cos 0 will be equal to the first value, which is 1. And sin 0 will be equal to 0. Let's write them a little differently. So cos 0 is equals to 1 and sin 0 is equals to 0. This is at point B. Point A. What happens at point B? At point B, your values are 0, 1. So cos of the angle formed over here. What is the angle formed? Here you have point B. So this angle is 90 degree. Cos 90 degree is equals to 0 and sin 90 degree is equals to 1. In radians, we know that we have to get used to the radian values or understanding stuff in radian values. So you can write this as sin 0 radian is equals to sin 0 degree. Sin pi by 2 radian is equals to sin 90 degree. Similarly, cos 0 radian is equals to cos 0. Cos pi by 2 radian is equals to cos 90 degree. Now, if you do not write anything, if you do not mention this degree or radian, it is by default considered as radian. So if someone writes sin 45 without mentioning degree, this can be considered as radian. Similarly, if it is written for nothing, then it is considered as radian. 4 pi radian. Sin 40 degree. Now degree is mentioned, hence it will be considered as degree. Continuing with this, at point C, we have cos. Now the angle formed from here to here, the complete angle formed is 180 degree. This is 90 and this is 90. Each quadrant covers a maximum angle of 90 degree. So 90 plus 90, 180 degree. (180 degree) is written as pi. So cos pi is equals to cos 180 degree. Now we haven't shown the radian sign. So by default, it should be considered as pi radians. This value is equals to the first value, which is -1. Sin pi is equals to sin 180 degree. Its value is equals to this value, which is 0. Next, cos this point D. At point D. At point D, you're covering 90 degree plus 90 degree plus 90 degree, which is 270 degree. 270 degree is written as 3 pi by 2 because it's 3 times pi by 2 value. Pi by 2 plus pi by 2 plus pi by 2 is equals to cos 270 degree, which is equals to 0, 1. So this value is 0 and sin 3 pi by 2 will be equal to sin 270 degree, which is equals to again -1. If you can see, your cos value is ranging from 1, 0, -1, 0. Next value, it will again attain point A. After D, again you'll have point A. So, but the angle covered will be from 0 to 90, 180, 270 and back to 360. So this line, this point 1, 0, these values are for cos 0 as well as cos 360 degree. So even if I write cos 360 degree is equals to 1, it will be the same, or cos 0 degree is equals to cos 360 degree. We know that angles are infinite in nature. So as you progress along, as you increment the value beyond 360 degree, you'll again reach to this point, then you'll reach to this point, and the cycle continues till infinity. What about negative angles? For the same circle, you can consider negative angles as well. Let's consider point A, B, C, D. But now let's go in the negative direction, in this direction. You have a line over here, you have this point B, this is cos x and sin x. By default, x x dash y dash. These points are, this is 0 comma 1, 0 comma minus 1, 1 comma 0 and minus 1 comma 0. Now what is negative angle? No? So from 0 degree, let's say this x value is moving in this direction. So the angle covered will be minus 90 degree. Because you're moving clockwise direction, the angle covered is minus 90 degree. So your sine minus 90 degree. This value is equals to 0, minus 1. And cos minus 90 degree is equals to first value, which is 0. Your sine minus 180 degree. That means you're progressing further and reaching this point. This would be minus 180 degree. This will be equal to 0 and cos minus 180 degree will be equals to minus 1. So if someone would have started with minus 180 degree for cos value angle, and x is equals to minus 180 degree, progressed to 90 degree, minus 90 degree, then 0 degree, 90, 180, 270, and then back to 0, which is 360 degree. Then your x value varies from minus 1, 0, 1, 0, minus 1, 0, 1. The next value will again be 0, then minus 1. This process repeats itself. What are the corresponding values for sine? Sine x. For minus 180 degree, you got 0. Then you got minus 1. For cos 0, for sine 0, you got 0, 1, 0, minus 1. So you have 0, 1, 0, minus 1. Then again 0, because this value will, these both values will be same. Your angle 0 degree is equals to 360 degree. Then minus 1, 1, 0, and so forth. So you have 0 once, and then you have minus 1. Then you have a 0, then you have 1. Then you have 0, minus 1, 0, 1, 0, minus 1. Now the importance of this, or the graphical representation of this, will be covered in further, maybe in the next class. But what we are trying to attain is, we are trying to just observe for which angles do you, what trigonometric functions, or what are the standard trigonometric values that you get for standard angles, as far as maybe the quadrant angles are concerned. Quadrant angles are some quadrantals, sometimes called as quadrantals. So these are quadrantals, quadrantal angle. All these angles, minus 180, 90 degree, 0 degree, anything that is the that lies any angle which is formed at the borderline of your quadrants. Now, by observation, let's consider for cos. Which values of cos are 0? Minus 90, 90, 270, okay, and so forth. So let's write them in radians. X in radians will be, in this table, minus pi by 2, 0, pi by 2, pi, 3 pi by 2, 2 pi. The next value we can guess is 5 pi by 2. And so forth. Now, what do we have here? This cos x is 0 for these values. For 90 degree, this one, this one, this one, whatever value you have here. So let's try and summarize this. Cos x is equals to 0 for which values of x? Then x is equals to minus pi by 2, pi by 2. So can you write plus minus pi by 2? What value is this? 3 pi by 2. So definitely for minus 3 pi by 2 also your cost value will be 0. Plus minus 3 pi by 2. For which other values? Plus minus 5 pi by 2. And so on. How can you generalize this? See, pi by 2 is common. Pi by 2 is common. What are the coefficients? You're getting cos x is equals to 0 for plus minus odd values 1, 3, 5. We know that odd values are written as 2n plus 1. Pi by 2 is common, where n is an integer. So if you have to write even values, then even values are written as 2n. It represents even values. Provided your n is an integer. And 2n plus 1 value represents odd values. Again, your n has to be an integer. You can try this out. So we know that integers means 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, and so on. 2n. 2 times 0 is 0. 2 times 1 will give you this 2. 2 times 2 will give you 4. 2 times 3 will give you 6. 2 times minus 2 will give you, 2 times minus 1 will give you minus 2, and so on. So you're getting even values if you consider the formula 2n. What about 2n plus 1? N is equals to 1. The 2n plus 1 will be 2 into 1 plus 1, which is 3. N is equals to 2. 2n plus 1 will give you 5. N is equals to 0. 2n plus 1 will give you 1. N is equals to minus 1. 2n plus 1 will give you minus 1. So if you can see, these values are all odd values. So you have to memorize, you have to understand, wherever you write 2n, it is even value, and whenever you write 2n plus 1, it is odd value. So by this, we've understood that cos x is equals to 0 only when your x value is equals to plus minus 2n plus 1 into pi by 2, where n belongs to integer. That means here n is called an integral value. N can also be called as integral value. Integral means related to integer. Z is integer. How can you generalize this? What do you understand about sin x here? Sin x is 0 for these values. Minus 180, 0, plus 180, 360, or that is, or in radians, minus pi, 0, pi, 2 pi, and so on. So write them. Let's write these. Sin x is equals to 0 for x is equals to either 0 or plus minus pi, plus minus 2 pi, plus minus 3 pi, and so on. Here, this is common. Pi value is common. They are preceded by 0, 1, 2, 3. 0 can be written as 0 pi. So x can be written as plus minus n pi. N can have a positive value. N can be any integer where n belongs to z. This is for sin x is equals to 0. So these are the generalized formulas, or basically to understand for which angular value you'll get 0. Now we also know that we've studied in the last class or revised in the last class that tan x is equals to sin x upon cos x, right? Here it is compulsory that your cos x should never be equal to 0, right? Cos x can never be equal to 0. That means x should never hold the value which causes cos x to be 0, which means x should never hold this value, plus minus 2n plus 1 pi by 2. Okay. Now, instead of writing this pi by 2, this writing of pi by 2 can also be avoided, because ultimately you'll get these values by default in all these situations. You may write it, but your textbook avoids it, so we will avoid it as well. So this is also the same. Cot x is equals to cos x upon sin x. Therefore, your sin x should never be equal to 0. Denominator can never be equal to 0, otherwise the answer will be undefined. That means x can never hold the value of n pi. In both these scenarios, n belongs to z. Okay. If you want to write this cos x formula in words, it can be written as cos x is equals to 0 for only when x is an integral x is an odd multiple of pi by 2. Sin x is equals to 0 only when x is an integral multiple of pi. Okay. Continuing with the earlier discussion, your sec x is equals to 1 upon cos x. By default, x can never be equal to an odd multiple of pi, which is pi by 2, which is 2n plus 1 into pi by 2. Cosec x is equals to 1 upon sin x. Therefore, x can never be equal to n pi. Now, we'll stop here. We'll continue discussing signs of different trigonometric functions and different quadrants in the next class. Thank you.